let's continue working through these particle motion problems from 4.1. So we're looking at 55. So a balloon is rising vertically with a velocity of 16 feet per second. 16 feet per second. Release the sandbag at an instant that it is 64 feet above ground. How many seconds after its release will the bag strike the ground? At what velocity will it hit the ground? So we know velocity is initial velocity is 16 feet per second. We know that our position is 64 feet. So we have two pieces of information that will help us plug in a little bit later. So we can say v sub 0 equals 16 and s sub 0 equals 64. Okay, so we're told that initially we start off with our acceleration function, negative 32 feet per second, and the integral of acceleration is velocity, so the integral of negative 32t. Just like with 53, we go through power rule. Negative 32t plus c, we can plug 0 in for t, 16 in for velocity. Solve for c, we get c equals 16, so we have our updated velocity equation. Next up, we're taking the integral antiderivative of our velocity function, which will bring us up to position. So integral of negative 32t plus 16 becomes negative 32t squared over 2 plus 16t plus c. We can solve for c by plugging in s sub 0 equals 64. So when we do that, the t's will wipe out. We solve for c equals 64. So now we have our specific position function to work with. How many seconds after it's released will the bag strike the ground? So the bag's going to strike the ground at some point in time after it's dropped from the 64 feet above ground. So we're trying to figure out how long will it take for 64 height, from the initial height of 64 to our final height of 0. So I can replace s sub t with 0, and then now it's just a matter of factoring. If I factor negative 16 out, t squared minus t minus 4 is not going to quite factor for us, so we have to go through quadratic formula. When we do that, we get 1 plus or minus root 17. We only want the positive value, so 1 plus root 17 over 2, which is 2.562 seconds. Part B, at what velocity will it hit the ground? We know that it's going to take this amount of time to hit the ground, so if I take this value, put it into the velocity function, I know that I can find the exact velocity. So if I plug 2.562 into t of the velocity equation, I get down to negative 65.9 feet per second.